Okay guys, I'm going to talk about one of the important topic in statistics, which is central limit theorems. So in short we call CLT, central limit theorem. So what is that? For a relatively large sample size of sample mean approximately normally distributed, regardless of the distribution of the sample mean under consideration, that is n greater than or equal to 30. If any sample size greater than 30 is automatically going to be normally distributed, regardless it is says or declared in the problem or not, it is going to be normally distributed. Okay, so we use the z table basically. Okay, now there is another condition here also. If it is normally distributed and sample size is less than 30, still you can use our z table. So we're going to note it down also. Okay, now I want to make sure we understand this one here on the bottom. According to the central limit theorem, the distribution of sample mean will approximately be a population mean, and a standard deviation will be given as standard error of the mean, which is sigma over square root of n. In other words, population standard deviation over square root of sample size. Okay, so let's do a problem. Let's take a let's take a look on the problem here. An engineer is going to redesign a car seat for Tesla. The population of driver has normally distributed weight with a mean of 155 found and a standard deviation of 33 found. If a driver is randomly selected, find the probability that his weight or driver weight is less than 134. Again guys, this is something we talked about before. Okay, so what is the information given? Let's find that out. So this is a mean given, right? So this mean is given, which is a population mean, and also population standard deviation. So I'm going to note it down. Population mean is equal to 155 and population standard deviation is equal to 33. I don't have any other number on the problem actually. So let's take a look on A. What does it say? If a driver has normal distributed, find the probability that his weight is less than 134. I think you know how to find this one down, right? Again, we must convert this into a z-score. Otherwise, we cannot actually use the z table. So z-score is equal to x minus population mean over population standard deviation is equal to x. In this case, this is the x. In the problem, always given is the x. So 134 found minus 155 over 33. Now we can use our little itty-bitty calculator, right? So clear it, and I can use this one, which is always safe. 134 minus 155, and you go down here, of course 33, enter. And of course this is a fraction. While you use double arrow, it gives you lots of decimal. Remember, we must round to two decimal place. So negative 0.64, negative 0.64. All we do, we just go to the z table and get the area. That's all. We go to the z table and get the area. So what is the z table? Negative 0.64. So negative 0.64. So negative 0.64, negative 0.6 and 4. So I want to actually make sure you understand that. Look, if it was, you didn't round it up. If you say 0.63, your answer would be wrong. 0.63, your answer would be wrong. This is technically your answer, 0.2611. 0.2611. So you must round things up, 0.2611. So your answer is 0.2611. That is the answer. Okay, well, this is not new actually, so we know this one already. Okay, now I have a second one down here. Okay, so this time, well, I can carry down the same thing up here. So what we have so far, I have the mean, which is 155. I have the standard deviation, which is 33, and this time I have 76. Here you go, 176. So this is x value, 176. I have one extra thing here, n. What is that? That is the n here. This time is given as n. Look at these guys. So n is equal to 35. Oh, sorry, n equal to 35. So this is n. N equal to 35. Okay. Now, what can we do? So this time, since it's given as 35 different drivers, right? Drivers. So this time you have more than one sample. Okay, again, this is 35. So sample size is greater than, n greater than equal to 35. Yes. So we're going to use z table. So of course you use the z score formula table. So z is equal to x minus the mean over something. Here we have to follow the central limit theorem. So what is the central limit theorem? Central limit theorem says, look at this here, standard error of the mean. So we use this piece here actually. Okay, this is also mean standard error of the mean, STNDRD, standard error of the mean. Standard error of the mean. Well, why we use that? Remember, if we don't use everything, there is always a possibility we're going to have some kind of error. So to minimize that error, we use this standard error of the mean by using central limit theorem. So it's going to be sigma over square root of n. Here you go. We have all this information. All we do is just plug this in. So x is 176 minus 155 over n is 30, sorry, not n, standard deviation 30. Let me check it out. What is the standard deviation? Oh yeah, you go. Standard deviation is 33. So over 33 divided by square root of n is 35. Okay, so we have to be very careful the way we type in the calculator. Okay, so let's take a look here. We have little itty-bitty calculator. Earlier I mentioned it. So let's take a look here. So we are going to let me see. I can actually do this one here. Okay, even I can actually check this out here this side. Yeah, that's fine. So you can see the whole screen. So I use this one down here, 176 minus 155 divided by, again you use this fraction here, that's lovely, 33 over second x square is going to give you 35, enter. Obviously this is a radical, you use double arrow, 3.76. So approximately 3.76. Here you go. So do this one here, approximately 3.76. So we are finding the probability. So we must go to the z table. So 3.76. Remember 3.76, which is positive. So we go down here, 3.76. Okay, so anything off 3.50 or off, our answer is right there. Our answer is right there, 0.9999, 0.999. So your area or probability is going to be basically, so area is going to be 0.999. Well, it's just erasing. I don't know why is that happening. but I think I understand why that happened here. Okay, so I'm going to actually make some room here. Okay, so yeah, that's lovely here, as you clearly see, 0.999. Yeah, that's the area. Okay, that's the area. Unless otherwise question asks for percentage, while this one asks for probability. So that is the answer here, as you clearly see. Okay. All right, so we have one more question here, right? So what is that? Find the probability that the mean for 20 randomly selected distance, well, actually, randomly selected driver. Yeah, I want to actually have this typo here. I'm going to say driver is greater than 197. So we do the same thing here. Quickly, I'm going to do this here. So we know the mean. So we're going to do the z is equal to x minus the mean. So this is the x, 197.80 minus the mean population 155. Remember this information is given earlier, 155 over standard deviation is 33 square root of 20. Remember this is the n, and those information was given in the original problem. What are those information? This one was given in the earlier, in the main one. Okay, those two was given. Now if we do this, and we can use calculator again. Okay, so it's gonna give me, okay, oops, sorry. So if I do use a calculator, I get well, you do this one, 197.8 minus 155 over 33 square root of 20. Enter. Is going to give you 5.80. So clearly, as you see, it will give us 5.80, approximately 5.80. And definitely still our area is going to be 10.9999. And question is, we use 20. Okay, we're looking for greater than. Do you think it makes sense here? No. Okay, why is not? Because we are looking greater. Okay, if we actually put down this one here, right? I mean z-score, that's the z-score, right? And you're looking something, and this is 0 and 1 2 3, and you're looking for 5 point something, so that cannot be this, no way. So are you forgetting something? Yes, absolutely. So your area is supposed to be 1 minus 0.9999. So it's supposed to give you approximately 0 or 0.0001. That should be your answer. Okay, now the last question is here. Why can the normal distribution be used in part C even though the sample size does not exceed to 30? The reason is because the original problem says is normally distributed. It's normally because it is normally distributed. Normally distributed. It's written on the original problem. That's why. Thank you.